This is the Helpful Hacker, and today we are going over SQLMap The Basics from TryHackMe. So we'll jump right in and get started. Here's the room. We'll get started with the introduction. So basically, what this introduction is going to go over, it's just going to give us a quick review of SQLMap and kind of what it does. Now, to really understand this, there is some infrastructure stuff that you kind of need to understand. So it's pretty straightforward. So if you take a look at this diagram, you have you in your browser surfing the web, and you go to tryhackme.com, right? And when you do that, you decide I'm going to log into tryhackme.com. So you send in your username and password, and that goes from your browser to the web server. And then the web server takes that username and password and says, cool, you gave me a username and a password. I need to double check to make sure that this is correct. And so then your web server will send that to a database. And the database will look through the whole database of all the people and decide, hey, either you're good, this is the correct username and password, or wrong username, wrong password. And then the database will tell the web server that, and then the web server sends that to your browser to let you know, hey, you logged in, or to let you know, hey, your username or password is incorrect. So that's kind of the basics of how this really works and the flow. So just like in our example where we're talking about logging into tryhackme.com, this is an example of a GET request to so we'll just say example.com in this case. That's what we have as the host. And it's to their login page. And we have the username, hacker, and the password 12345. So when we go to a website to log in and we type in our username and our password, and then we hit submit, this is the kind of request that gets sent to our web server. Now, this is a GET request, which I'm showing you because the example they use in TryHackMe is a GET request. However, in real life, more often than not, it's going to be a POST request. And a POST request is going to look something like this, right? It has the POST instead of the GET, still to the same host. And then we can see at the bottom is where it's going to put our username, hacker, and password 12345. So that's what we're sending to the web server. Now, what does the web server do? So I just wrote this. This is in Python because that's what I tend to use more often than not. A lot of web servers are written in like PHP and in other languages, but just this isn't to help you understand how to code web servers. It's mostly just to get the point across. And so here we have, this is Python. So we're basically grabbing all of that right there is a long way of saying, hey, the web server, it's going to grab your username and your password, and then it's going to do something with it, right? Because it needs to send that to the database. So what else is it going to do with it? Well, I will show you right here. So this is what it would look like. So now the web server, it's grabbed your username and your password, and now it's going to run some code that'll look something like this. And basically what this does is this is connecting to a database, and we can see that right there. So it connects, and then it's going to execute SQL, which is where we get SQL injection, right? So it's going to set up the whole query for us, and then it's going to pass our username and our password. So here we can see it's going to select everything from users where username equals question mark and password equals question mark. Now, in SQL, that question mark is like just a placeholder. And what's nice is because we're using a question mark in this example, this is a very secure placeholder. And then, so we have the query all highlighted in green, and then we will separately pass our username and password. And what this does is this makes it so that no matter what we put for the username and password, it's not going to get treated like code. It's just going to be treated like a string, right? And so this is what a secure version of a web server handling SQL would look like. So it's handled the SQL. It's got our query all ready to go. It has our username and our password. Now it's going to send that to the actual database, right? And that is going to look something like this. So what the database sees is the database gets the query at the top with our placeholders, and then it gets our two parameters, right? And so with that, it's going to replace hacker and 1, 2, 3, 4, 5 into those question marks in the final statement that we actually see is right there at the bottom. And that's our SQL. And if you don't know SQL, I have another video kind of explaining SQL, all the syntax and stuff like that. So this is a bit more intuitive, but honestly, SQL is pretty straightforward. It's going to select everything. That's what the asterisk marks means. It's just grab everything from users, which is a table where all of the users are stored. And so it's going to grab everything from that table where the username is hacker and the password equals 1, 2, 3, 4, 5. So then it's going to grab that one specific user that meets those two criterias, and it's going to send it back to the web server. And then that web server is going to send it back to us in our browser. And then we're able to log in and we're able to use TryHackMe as ourselves, right? So now that we have some background on how this actually works, this first introduction section will make a lot more sense and be really straightforward. You should still read through it, but at this point, you honestly probably have a better understanding than that blurb is going to give you. But just to confirm your understanding, I recommend that you go through, you read that, and they have their own nice little diagram right here that you can take a look at. So part of this, you're going to want to have most likely taken a look at the SQL fundamentals. Now, it's not totally required. They recommend it because it will just help you. But if you haven't, I go into enough detail that you'll probably be fine. So now down to the question, which language builds the interaction between a website and its database? That would be SQL, right? Because that's going from the web server, so the actual website, to the database and back and forth. So submit that. And with that, we are done with task number 1. Now it's on to task number 2, SQL injection vulnerability. So I already kind of explained how it works the normal way, right? How a web server should handle stuff and how things should play out and how everything should communicate. And it's really not too complicated, but still, even today, you can find SQL injection vulnerabilities because web servers don't always handle things the way that they're supposed to. So you can read through all this first, or you can listen to the explanation and then read it after. Either way, but I'm going to go through this real quick. So what we're doing here is it's still going to go from our browser to the web server, from the web server to the actual database, right? So this still starts with us using a GET request or a POST request and sending that to our web server. Now, here's the difference. So in these GET and POST requests, I'm using hacker and password 12345, which are totally normal usernames and passwords. But what happens if we start trying to inject SQL? So instead of putting something like hacker and password 12345, what if I put something like select all from tables? How's the website going to deal with that? Or how's the web server going to deal with that? And let me show you what happens when we try to hack a secure web server. What gets sent to the actual database, right? And what happens is if we tried to hack it by using something like hacker or 1 = 1 -- comma, and then at that point you could put anything into the password field, because if we remember, we have our username and our password. So what I'm trying to do here is I'm trying to say hacker or 1 = 1, which is always true. And because 1 = 1 is always true, then the statement is true. So it should select everything from users because the statement is true. So it'll just dump all the usernames and all the passwords for me if this works. but it doesn't work. And the reason why it doesn't is, again, because this is a well-done web server. It takes our query and it puts it up there at the top with the question mark as placeholders, and then it puts in whatever we put in becomes strings. And you can tell that down here in the final statement because it's all in green, right? And that's because they just, escape everything that shouldn't be there and they make it one big string. So it doesn't really work here, okay? And that's because, again, this is a secure web server. So if we jump over to an insecure web server, so this would be an insecure web server. And what's happening here is we create our query, right? And inside the web server, so this isn't the database that's going to do this. Now it's the web server. We're going to input the username and password directly into our query. So I'll just to kind of explain how this works. It's the exact same as the other one, basically. So we make our connection to our database, then we build our query. And that's going to be select all from users where username equals. Then you have this %s. And what that is that's a placeholder, just like the question mark, but a little bit different because this is a placeholder for Python because we're actually going to build the query. And you'll see what I'm talking about here in a second. So then we have and password equals, and then we have the same symbol. Then at the end of that statement, we have this %username password. So what's going to happen is instead of the database handling the query and using its question marks and just taking our input as strings, instead, inside the web server, we're going to just make the whole thing. And this isn't a great idea because what can happen, or what's going to happen, is whatever we put in username is going to get plugged into that first %s, right? So whatever we put in there, that's going to get plugged into %s with the two quotes around it, right? So what that end result looks like is this, okay? And that is because now if you look what's happening here, notice how the hacker or 1=1 ... that's no longer green. And the reason why is because our web server just took whatever we put in as username and put it in between quotes. That's all that our web server did. So because of that, we're able to put our payload, which is hacker, comma, and then that ends the first part. So now we've closed that parentheses. Now we've closed that quote. Then we have or 1=1, and those two dashes right there, that's going to comment out everything else. So it's like everything else doesn't even exist. So now instead of our web server sending a normal query to the database, now it's going to send this. And because 1=1 is always true, the database is going to return everything. So it's going to return all the usernames and all the passwords, right? And that in essence is how SQL injection works. Now, it can get a lot more complicated because there's lots of different kinds of SQL injection. There's lots of different payloads you can use for different reasons, depending on how the web server handles it. That was just a really basic, straightforward example because I think it's important that you understand what's going on under the hood when you learn about these tools like SQLMap, because SQLMap is great and it's going to do a lot of this automatically for us so that we don't have to manually test all this stuff out. So now that we've gone over that, you should take a look at this. They're using the exact same example. It's a login, username John, password undetectable 444. And so it explains how that works. It talks a little bit about sanitization, which is important. And another keyword you might want to know, parameterized queries. I think I said that right. But that basically means when we were looking at our secure version of our web server, we noticed that we have the question marks, right? And that is helping us parameterize our queries so that our input it can't be read as SQL. It's only going to be read as a string, right? So that's what parameterized queries helps with. And then down here, they explain kind of their payload, very similar payload, except what they do is instead of just doing the dash dash like I did, they end the SQL statement, then they do a dash dash space, another dash, comma, or quote, and then semicolon, right? And they have their reasons for that. And if you read through, you can kind of see that. But I personally like the other example a bit more. It's just more straightforward. We're putting in those two dashes to comment out everything else. So everything that comes after it doesn't even count as a query, right? And that's basically what they're doing here, right? With the dash dash. So make sure you read through this and then we'll answer the questions. Which Boolean operator checks if at least one side of the operator is true for the condition to be true? That would be or, going back to some basics, and or operators. So if you read the section, you should understand that, or if you just code in your free time, you'll understand this question. And then is 1 equal 1 in an SQL query always true? Yay, it is, right? And again, that's how we're doing the SQL injection. We're giving the SQL something that is always true. So then no matter what we put for the username, it doesn't matter. Because the statement is true. And so we're going to get everything that we ask for. So mark those complete. And with that, you're done with task number 2. Now it's on to task number 3, automated SQL injection tool, or in other words, the whole reason we're doing this room, SQLMap, right? So SQLMap is a super awesome tool. And with tools like SQLMap, what I like to do is honestly just go over the syntax first. Because most of the time with tools, if you understand the required syntax to do what you want to do, you can kind of figure the rest out for yourself. So this is just going to be a dump of all the syntax you're going to want to know. So first, the command SQLMap. What does that do? That's actually going to start the SQLMap tool. Pretty straightforward, like most things. Then we have the -u flag, and that stands for URL. So this is going to be the URL that you actually want to attack. Now, we're going to do this in our example, but when you do put the URL, you want to make sure it's, in this example anyways, that it's the URL with the actual parameters in there, because that's what we're attacking, is those parameters inside the URL. And it's important that you put single quotes around that URL, because sometimes there's special characters in a URL that can mess up SQLMap. But if you put single quotes around that URL, then you're totally fine. Then we have the -dbs flag, and that's the flag to see all available databases. Then after that, we have --tables. That's a flag to see all of the tables. Then we have --dump, and that flag is going to dump whatever is inside of a table. So you pick a table and then you do --dump, and it'll give you everything in there. Then I don't even think we're going to use this one, but in the future, as you use SQLMap, you'll probably want to know --columns. That's going to list all of the columns in a table. We have --dump all, which dumps everything. You could use that. Once you get into this room, you'll kind of see why that's not the best idea. More often than not, it's better to be have a bit more precision. And I'll explain that in a bit. And then we have the -d. So once you've figured out the database you want to attack, -d is the flag to tell SQLMap which database you want to look at. And then same thing with -d, except for that's going to be for the table. So once you know the table you want, you can put that -t flag, and that'll be followed by your table name. And that's the table that you're probably going to be dumping. Now, --help, that will give you a basic breakdown of SQLMap and how to use it, right? So now you know some of the basics. A couple of other things that aren't in this example that they give us, but are really useful, are requests. So SQLMap, you actually can take a full request from like Burp Suite or whatever proxy you're using, put it into a file, and then use that file instead of a URL, which is really cool and super useful. And in the real world, I would argue that's probably the most efficient way to do it. If you're doing web app testing, you're probably going to be using something like Burp or Zap. And then you'll want to just take the request because you have it, throw it in a text file, throw it into SQLMap, and it'll run it for you. Even though now, I mean, there's a bunch of stuff you can do inside Burp Suite to automatically find a lot of these. But still, SQLMap is a good tool to know. So that's one useful thing that they don't include here is you can just use a request instead of a URL. But anyways, wanted to mention that. And then the other thing I wanted to mention that I almost forgot was the -- dump all. You don't want to do that because it's loud and it's slow and databases can be huge. So what makes more sense is to do what they're going to show us here in the example. So in their example, they have SQLMap. Here's the URL, and they have that search, and then they have cat equals 1, right? So then it uses the -- DBS flag. So that's going to search all of the databases. And if we look down here, we see there's 2 available databases, users and members, right? So now that it knows all of the databases, it can pick one. So instead of having to wait and scan both of them, you can pick the one you want. So then the next thing that they do in the example is they use -D flag for the actual database because now they know they want to look at the users, and then they do -- tables, and that will dump all of the tables for them. And then if we look at their results, there's 3 tables, and those tables look like 3 different users. So now we can even pick the specific user that we want to look at. And so hopefully you can see how doing it one step at a time is more precise than just saying, hey, give me everything you can. So that's how I would recommend you use this. So then here they kind of put it all together. They have the -D flag for users, the -T flag for Thomas, and now they're going to dump everything inside the Thomas database. And if we look, we get the date, probably the date that the database entry was created. We get his name, and we get his password, right? So with that, you have SQL injection, right? You were able to get all that information, and now if you want, you can log in as Thomas and do all sorts of stuff. So, and they actually do mention it right here. So this is actually useful. This is testing an intercepted request. So you can do the -R flag, which will allow you to throw a request in there, and then SQLMap will go through and try and do that for you. And so that's learning how to intercept and capture post requests, which they're saying is out of the scope of this room. But as you saw earlier, this is kind of what that post request would look like. So you would take that, throw it into a text file, and then you could run SQLMap against it. And that's a really good thing to try if you have time on your own, because in real life, more often than not, stuff like login credentials, those are going to be inside post request or any sort of credential, right? But SQL injections don't have to happen where there's credentials. Again, it can happen in the URL. It can happen anywhere that there is user input and some sort of search functionality most of the time. There's probably some sort of database involved. So keep that in mind. Now we'll answer our questions. Which flag in the SQLMap tool is used to extract all the databases available? That'd be -- DBS. What would be the full command of SQLMap for extracting all tables from the members database? And then it gives us the URL. So the first thing you'd want to do is SQLMap, right? Then we have our -U flag. Then after that, I'm going to just copy the URL here because I'm lazy. Now, one thing that they don't include here is the single quotes around the URL. Like I said, especially once we get to the practical exercise and just whenever you're using SQLMap on your own, better safe than sorry. Just use them. That way you won't run into any issues if you have a URL with some special characters. So then we'll want the -D flag for the database. And the database that we're going to be using is the members. And then the last part is we want to extract all tables from the members database. So that will be --tables, right? So that is our full command. So mark that complete. And with that, you've finished task number 3. Now it's on to task number 4, the practical exercise. So I've already started the machine. So we'll jump over there. And what they want us to do, actually, before we jump over there, is there's a page. It tells us where it's hosted at. It's a login page. And they're going to want us to jump in there, use inspect to grab the URL. Okay, and this is the final URL. You could just copy this, but I really recommend in real life, if you were doing something like this, looking at a website, whether it's through Burp Suite, which is a bit more user-friendly, or using the actual dev tools with your browser, you want to know how to do this. So don't just copy it. Actually go through all the steps. It'll help you in the long run. So we're going to paste that URL and travel to it. Now if I right click, I can go to my inspect. And that brings up my inspect. Now I want to go to the network tab. Now there shouldn't be anything in there yet, but I'm just going to do ASDF, and ASDF is my password. And then when I hit continue, we'll see here is a GET request. And if we look at it right here, here is the URL that we want, right? It has that full URL. So I'm going to copy that because we're going to want to use that later. So now that we have that, we can minimize this and open up a terminal. So in our terminal, it's probably going to have us do a few things. And here again, they remind us that if you want to do this right, you're probably going to want to use the single quotes. Okay. So now let's get down to the questions. How many databases are available in this web application? So to figure that out, first, we'll put our command together, SQLMap -u for the URL. And now I'm going to paste that URL that I grabbed, right? But can't forget, because I've been telling all of you to do it, single quotes, right? This is going to make our life better. And then we want the --DBS flag because we want to dump all of the databases first. Because again, you want to be more precise. You don't just want to scan the entire database. It would take forever. It would be a pain. And hopefully if the people on the other end are any good at their job, they would know that you're there. So we're just going to ask for the database. Now this will run. What will happen is it's going to start asking you some questions as this runs. And just to be safe, you can just hit the capital, whatever option is the capital letter. That's the option that you should go with because that's what SQLMap recommends. So here's our first one. It looks like the backend DBSM, so database management system, is MySQL. Do you want to skip test payloads specific to other databases? So yes, I don't want to waste my time. If they already know or if they have a good idea that it's MySQL, I'm not going to waste time trying to do other ones. So for the remaining tests, do you want to include all tests for MySQL extending provided level 1 and risk 1 values? So here SQLMap is basically asking me, how deep of a scan do you want to do? And then it says extending provided level 1, and then it provides a risk level 2, which is also level 1. So it's saying how deep of a scan do you want to do and how risky do you want your scan to be? And earlier when I talked about dumping a whole database, like I said, if someone's good at their job, on the other end of that, they should hopefully recognize what you're doing. So if you keep the risk value down, then that means we're not going to be as noisy. Our payload won't be as risky, because sometimes you can attempt SQL injections with payloads that may delete data or cause other side effects or crash things, right? So we're just going to keep it safe. The scans do take a little bit longer, but this is what it would actually be like if you were trying to do this without totally getting caught. Then it says the target URL appears to have 4 columns in the query. Do you want to retry to find proper union column types with fuzzy testing? So it gives you the option of yes or no. So what this is basically asking is it's saying, hey, we're pretty sure it has 4 columns, but do you want us to try and find, that number of columns using fuzzy testing? And I'm not really going to get into how that works, but okay, I lied. I am. But basically what it does is it's just going to send different queries, and then it's going to try different union column counts and see how the web server or the database responds to those queries, right? So again, we're just going to play it safe so that it works and go with the default, which they say is no. So we're not going to look at that. And then injection not exploitable with null values. Do you want to try with a random integer value for option union character? Again, we're going to say yes. So this just has to do with kind of more in depth about SQL injection than I really want to go. But a lot of times when you're trying an SQL injection and finding columns and all that and the different types, you'll use a lot of null values, but sometimes that doesn't always work. So you can try using integer values as an option. So they recommend they do that because it looks like it's not exploitable with null values. So we'll hit enter with yes. And then do you want to try with a random integer value for option union character? I thought I already said yes to that. Okay, sorry, I was looking because I thought I had already said yes to that same question, but it's not. This one says target URL appears to have 4 columns in query. And then the next time it asks me, hey, target URL appears to be union injectable with 4 columns. You can't use null values in that injection. Do you want to try with a random integer? So now they're saying this actually looks injectable. Do you want to try? Now here it's saying checking if the injection point on get parameter email is a false positive. Get parameter email is vulnerable. Do you want to keep testing others? We're going to say no. So they found a vulnerable part. And if we look back at our URL that we initially used here, so they tested this email section first because that came first in the URL. They're basically asking us, hey, do you want us to test password too? And no, we already found our injection point. So we're just going to do what they recommend, capital N, and then we have to wait. Okay, so here it's saying you don't want to stress the network connection. Basically, what they're trying to do is they're trying to keep the risk level low, but also not take 1,000 years, right? So it's saying, hey, do you want us to optimize values for the delayed responses? Basically, hey, do you want us to kind of optimize this with all your settings so far? We're going to try and optimize this to work for you time-wise. And they recommend yes, that you optimize that. So we'll do that. And now if you look, it's starting to actually grab the database names, and it will slowly add a character at a time. So now we just got to wait, and eventually it'll have grabbed all the characters from all the databases. Okay, so that finished. And as we can see, we have 6 different databases. These are the different names. So let's go jump over here, answer question 1 with 6, hit submit. And that's correct. Now we want to know what is the name of the table available in the AI database. So to do that, we'll hit the up arrow. That's going to bring down our last command. And instead of --dbs, we'll do -D. And that's because we actually know what table we want to use. And that's the AI table, right? And we know that because it's asked us right there, what's the table available in the AI database. Did I say table? I meant database. So we're looking in the AI database. And what we want is to know the actual tables in that database. So what is the name of the table available in the AI database? That's nice. I think that means there's only one. So we will enter that. Okay, so turns out that my VM just kind of crapped out, I guess, you know. So that's a great time to explain that, you know what, technology is technology and it fails. So don't feel bad if you're doing these rooms and you have to like restart multiple times. It happens. So I just restarted. I already know that the database we want to look at is the AI database. So now I'm just going to go straight to dumping the tables. So I'm going to do that. It's going to ask me a bunch of stuff. I'm not going to make you sit and go through it because it's redoing the whole thing. And so I'm going to skip ahead to the results. But again, if it asks you more questions, just go with their recommended response, which will be the whatever capital letter option that they give you. Okay, so mine finally finished and we got the table user. So we can plug that in to our question. User, that's the available table in the AI database. What is the password of the email test@chatai.com? So how would we do that? We'll just hit up, and now instead of the --tables -t, we know our table is user, and then we can do --dump, and that's just going to dump everything in the table. And if there's a password in there for that email, we should be able to find it. So hit enter, and then just give it the generic responses again, whatever the capital letter is. That's the option it recommends, and this should finish in a bit. Hey guys, if you've made it this far in the video, you've probably found something helpful. If you have, please give the video a like and subscribe. That helps me out a ton. If you want to support the channel even more, please consider joining and becoming a member. Members receive some special perks like access to Q&A live streams, some behind the scenes videos of me going through TryHackMe rooms for the first time, and access to Discord roles. And as a reminder, my Discord is anybody can join it. There's a lot of great resources there. And if you need help with TryHackMe with a specific room, you can post any screenshots you have there, and it'll make it a lot easier for the community to help you out. Thanks for watching so far, and please enjoy the rest of the video. Okay, so that finished, and we got our results. The password is 1234567 So let's put that in and submit. And with that, you have finished SQL Maps The Basics room from TryHackMe.